Okay, so last time we computed a limit that looked somewhat like this. Not exact, but along these lines. Actually, I'm writing the exact same example. And if you remember, the first thing we did, we evaluated at x equals to 5. So we did the square root of 5 plus 20 minus 5 all over 5 minus 5. And then if you remember, we did the square root of 25, which was 5 minus 5, 0, over 5 minus 5, 0, and we said we want to factor. So we did that a few times back. And the question now is, what do we do? And what we did was we multiplied times the conjugate of this expression, but some people do not like the mess that comes out of it because it becomes algebraically a little bit more complicated. So one way to do it where we can continue to factor is by making a substitution. So this is a different method to solve these types of limits, which boils down to the same thing we did before, as you will see. But if you make that u, and you have to consider that as x goes to x, let's x that, and write as x goes to 5, u goes to the square root of 5 plus 20. So as x is going to 5, this is tending to the square root of 5 plus 20, which is going to be equal to the square root of 25, which is 5 again. So with that then, we can rewrite this expression as the limit as x goes to, as u goes to 5 now. And instead of x, I'm going to write this as u minus 5. And right here, I have an x. So I have to replace that x with something else. What I'm going to do is from here, I'm going to do u squared is equal to the square root of x plus 20, the whole thing squared. The square root and the square cancel. And I get then that x is going to be equal to u squared minus 20 by subtracting 20 on both sides. Using that expression, I want to put it here in place of x. And I just transform my limit from something that had square roots to something that is very simple to deal with. This is when you see there's a difference of squares, which is essentially the same thing we had done before, but is more clear here because now we're factoring rather than doing the completion of the squared. Not completion of the squared, multiplying times the reciprocal rather. Conjugate. Multiplying times the conjugate. I got it wrong 3 times. So instead of multiplying times the conjugate, we're just taking the limit by doing a difference of squares. And here we get 1 over 5 plus 5 by computing the limit, which is 1/10. So that's another way of computing these limits that doesn't involve doing the conjugate, but it does require a u substitution. But it depends whether you're more comfortable doing this or doing your conjugate there. So there's 2 options, so you can pick which one you prefer. All right.